What if I told you that the soft, flexible tray you bake cupcakes and was born from sand, heated to temperatures hotter than lava? Think about this. Every time you pull a perfect cake from silicone bakeware, you're holding a material engineered to survive extremes most metals struggle with. You trust it in your oven at 230 degrees Celsius, but most people never think about how it's made. And this is where it gets truly extraordinary, because what looks simple is actually a global journey of chemistry, heat, and precision. Stay with me, because what happens next surprised even experienced engineers. Imagine standing inside a factory where the air smells faintly of chemicals and heat pulses through the walls. Giant machines hum as liquid silicone flows like thick honey into steel molds. You hear a rhythmic hiss. Pressure, heat, precision, all perfectly synchronized. But here's what nobody tells you. This material can withstand temperatures from minus 40 degrees Celsius to over 260 degrees Celsius without breaking down. And the journey to reach that level of perfection begins thousands of kilometers away, in places you would never expect. Your silicone bakeware starts its life as quartz. Yes, ordinary sand. Mined in countries like China, the United States, and Brazil. Massive excavators dig deep into the earth, pulling out tons of silica-rich rock every hour. Each ton travels hundreds, sometimes thousands of kilometers to refining plants. There, it's heated to around 1,800 degrees Celsius, over 3,200 degrees Fahrenheit, separating pure silicon from oxygen. And here's the shocking part. Just one batch can cost tens of thousands of dollars before it even becomes usable. But we're only at the beginning. Once purified, silicon reacts with methyl chloride gas in a process that feels almost like controlled chaos. Inside sealed reactors, at about 300 degrees Celsius and under pressure 2 to 5 bar, silicon transforms into methylchlorosilanes, the building blocks of silicone. The smell is sharp, almost metallic, and the reaction happens fast. Most people never think about this invisible chemistry happening behind everyday products. And yet, one wrong temperature or pressure spike, and an entire batch fails. So, how do factories control something as volatile? Now comes a transformation into silicone polymer, a thick, rubber-like substance that feels almost alive in your hands. The mixture is heated again, carefully controlled between 150 degrees Celsius and 200 degrees Celsius, while catalysts trigger long molecular chains to form. Machines spin at hundreds of RPM, blending the material into a smooth, elastic mass. You can hear the low rumble, feel the vibration under your feet. And this is where it gets truly extraordinary. This flexible material will soon become something you bake your food in. But shaping it? That's a whole different story. Inside molding machines, silicone is injected into steel molds at pressures reaching 100 bar, over 1,400 psi. The molds are heated to around 180 degrees Celsius, curing the silicone in just a few minutes. You hear a sharp clamping sound as the molds close, followed by a quiet pause, then release. Perfectly shaped trays, molds, and baking tools emerge, still warm to the touch. What happens next surprised even experienced engineers. Because even now, the product isn't finished. Every piece undergoes post-curing in massive ovens, sometimes for up to 4 hours at 200 degrees Celsius. This removes any remaining chemicals and strengthens the material. The air smells warm and slightly sweet, like heated rubber. Workers carefully inspect each batch, trimming edges by hand when machines can't achieve perfection. And here's the twist. Despite all the automation, human touch still decides whether the product passes or fails. But how do they ensure something you bake food in is completely safe? Advanced AI cameras scan every millimeter of the product, detecting defects as small as 0.1 millimeters. Laser sensors check thickness, flexibility, and structural integrity. If even 2% of products fail, the entire batch can be rejected. Certifications like FDA and LFGB demand strict testing. No toxic residue, no structural weakness. But here's what nobody tells you. Sometimes, a human inspector can spot flaws faster than any machine. And this balance between technology and instinct keeps quality at its peak. But how big is this industry really? Globally, over 500 million silicone bakeware items are produced every year. The market exceeds $2 billion annually, with China producing nearly 60% of the world's supply. Thousands of factories employ millions of workers, all contributing to something that fits in your kitchen drawer. Over the last 50 years, silicone has replaced metal and plastic in countless applications. And here's a shocking fact. Silicone bakeware can last over a decade without degrading. But the future? It's evolving faster than ever. Imagine bakeware that changes color with temperature or integrates smart sensors to track cooking. Researchers are already developing next-generation silicone with enhanced durability and eco-friendly properties. And this is where it gets truly extraordinary. The same material that started as sand is now becoming part of smart kitchens worldwide. From ancient minerals to advanced engineering, the journey comes full circle in your hands. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.